Can you see my screen?
Yes, we can.
Okay, so this is Feb 2026, the Trailblazing Analytics US. We used to be called Chicago Data Tribe Meetup, and then last year we were told that we can join the Trailblazing we can be a part of the Tableau user group. So thank you, Tableau, for letting us do this. And after lots and lots of discussions, we became the Trailblazing Analytics US. There's also Trailblazing Analytics India. There's also Trailblazing Analytics UK. There's also one in Dubai. So there are 4 of us in 4 different parts of the world. Having said that, this is the first meetup for 2026. Thank you, Phillip, for accepting the invite to do the data visualization. And let's get started. So our agenda is welcome. Welcome everyone to this meetup. You can keep your camera on, you can keep your camera off. We do not care about that. But as part of the welcome, I would like to say that please ask your questions in the Q&A section. You will find at the bottom of your screen, and that would be easier for Jen and me to keep track. There may be things we can answer. There may be things Phillip will take over, but we will try doing as much as we can to help answer all your questions. Ideally, let Phillip finish his presentation, and then we will go one by one and ask the questions that that you have, instead of interrupting him all through the presentation. Last but not the least, there will be networking at the end. If we finish early, you can hang out with us, and if we can talk about anything else. Does not need to be CRM analytics, does not need to be data. It can be anything. Let's start with the icebreaker. So if you could learn any new skill instantly, what would it be? And you can absolutely put it in the chat for now.
Does it have to be data related?
No. No. Can be anything.
There's what I can actually do and what I wish I could do.
Yes.
Oh, I love that. Farsi. Yeah.
Okay.
I'll join you on that one. Data modeling. Data modeling is not as hard as you think, right? You just
exactly.
Draw it.
Actually, Jen and I have so this year we are starting with Phillip, but every 2 months, the usual schedule that we follow, we are going to do data 101. So of course, Phillip, you will do LLM. You do LLM all day long.
I hope you got the storage for that.
Yeah. But yes,
Good
sorry.
point.
But yes, we will be doing a lot of 101s data. And you guys are free to join. Tell us how you want, what you want to learn next, everything. I will actually send out a form after this. So if you want to hear from us about topics, let us know. And we do call ourselves Trailblazing Analytics. One big reason being we just don't do Salesforce. We also do AI at times. We also do Data Cloud, which is now Data 360. We also do Tableau Next. And we talk just about data, about anything that is related to data.
We did the APIs on Halloween.
We did APIs on Halloween, which was a nightmare to do on a night.
I love it, but everybody else thinks it's hard.
Yes, but yeah, we can do that.
Congratulations, we have a recent certified
CRM consultant.
Good for you.
Yeah.
I don't do tests, so people will just have to go on my word.
Also, Phillip, if you can put your LinkedIn profile, if people can tag you.
Sure, right away. Give me a second.
Get those followers.
And then I'm going to ask Phillip to introduce himself and start his presentation.
We're all family here. We're all connected by a singular gene for data somewhere in our family trees, right?
Just paste my LinkedIn profile at the comments. the discussion.
Perfect.
Thank you.
That's great.
So, Philip, all yours.
Hello, everyone. Good morning, good evening, and good afternoon. Uh, I hope you are all feel very welcome here in our event. Thank you, Sayantani and Jenny, for inviting me. And as we say in Brazil, sejam muito bem-vindos. This event is about CRM Analytics, of course, but in this event, I'm going to do something that I never done before. That is getting drilling down into the specific advanced kind of visualizations in CRMA, the kinds of the ones I've been experimenting to and posting videos and LinkedIn, etc. So I hope you guys enjoy and let's get into it. I'm sharing my screen right now. Please tell me if you guys can see my screen.
We can.
Perfect. Okay, so let's start with the event. As you can see, we have a dashboard right here. Wow, it's a very simple and poor dashboard, a single bar chart that displays a grouping, a metric, which is the aggregation, this is the size of the bar, if you prefer, and also the sorting order. As you can see, it's sorted from the highest value to the lowest value. And I inserted here a grouping, another grouping, sorry, interaction, where we can change parameters within our query and our widget. So we can change all of these things at once. And we will see on the background what's happening. For example, here we are grouped by account, sorted by descending order, aggregating the amounts in a horizontal bar chart. But if we switch to owner, we will change to a vertical bar chart in ascending order now, grouped by the owners of the records. So we change the grouping, the chart type, the sorting order, do you know, and the title as well of our chart with a single change into the grouping. And the same thing for contact. Now we change again the chart type. It's a pyramid chart sorted by on the left side, the highest to the lowest. The title is again changed. The theme is also changed. This is, I think it's Walter Dark, the name of the theme. And if we change by country, again, we are changing just the grouping, but the chart visualization to a map now. You know, from stage, we are see the funnel type of chart stacked by the stages. Okay, if we change by the type, we are now stacking a stacked column chart, a stacked bar chart, sorry, where we are presenting now, instead of aggregations of a metric, the percentage distribution of each group type within the first group. We have the first group called upsell, that is the main grouping, the opportunity type, which is upsell, cross-sell, etc., each one of the values. But we also have another grouping within our bars that displays the colors of our bar and the percentage corresponding, meaning that 74% of our opportunities of the upsell type are open. We have 10.56% of the upsell type that are closed won, and 15% and 15.44% that are lost. And we are going to see again a close date chart. We change again the visualizations, and now we're displaying in a line chart, which is the best visualization, in my opinion, for a trend comparison against year by year or date by date, whichever date period you prefer. And the last one, we are projecting now. All of the other ones, we were projecting a single metric that was the sum of the amount, the accumulation. But here we are projecting now two metrics in a combo bar chart, the sum of amount and the unique contacts by each one of our dates. Okay. And how can I do this type of change and manipulation within the queries and within the charts themselves? The secret is with the interaction that I insert here. where if we can see, I think it's best if I show you first the dashboard code. If we hit Command E in the dashboard, we can see what's happening behind the the scenes here. We have the data set that's being loaded, we have the query, we have the bindings and the interactions, etc., etc., etc. So if we open our chart right here, oops, sorry, in the advanced editor, we have the widget properties and the query properties as well. To change things like what's being projected, what's being grouped, etc., etc. For example, the number of metrics, like here, we are presenting two metrics, and here we are presenting two groupings, three groupings, sorry, with a single metric. Three groupings within the date group. We have the date group, and within each date we have three groupings. Okay, to do this, the place that we will change our metrics, our interactions, are here within the query itself. The query is the place where we insert the results of our selections in that interaction that are inserted over here. But that by itself doesn't only change. Only changes the groupings and the metrics that we are visualizing in our chart, but doesn't change the chart type, doesn't change the text that is being displayed right here, doesn't change if we are seeing a percentage or a stacked column chart by aggregation or by percentage. That this is a normalization of what we are seeing right here. So we have also to insert the parameters within our widget component, where we can insert each one of our components and change it based on what we need for the visualization. For example, the most important one is the visualization type. This is what will determine if you're going to see a vertical bar chart, horizontal bar chart, a map, etc., etc., etc. So this is also inserted here in my display. If we select here, look, we have several columns different that passes values to our query and to our widget properties as well. For example, we have the visualization type, data point chart, that's the one. For example, if we select the first, the chart presented will be a horizontal bar, H bar. The second one, vertical bar. Okay, and we have no map. When we have the map, that is the country grouping, we will have the chart and the map as well. We have two properties instead of a single one. So we have to insert all of this within our widget to make sure we can change between one chart type and another. And how do I know the properties of each chart? Because each chart is different. If you notice, if we create a really quickly a query right here, if we select, for example, an account, a country, and let's select a stacked column chart, like this, and we create this new query right here. If we click on the properties, we will see, because we selected a stacked bar chart, we will see the properties of that we can edit here on the right side for a stacked column chart, each one of these properties right here. But it doesn't contain all of the properties. So we need to insert also the properties that exist in other chart types if we're going to present them, like if it's a map, like I show, if it's a timeline, if it's we'll see in the front a chart called the heat map as well. Okay, so the bottom line of this first presentation is to understand that we can bind and pass values to our query and also to our widget properties here in CRM Analytics, making it possible to switch both the chart type and the chart properties and the query groupings and etc etc etc, making it very customizable and very dynamic. Okay. For example, one thing that I like to show you that is possible to do is a histogram chart. An histogram, I don't know, I'm assuming most of you already work with data. Basically, a histogram is a vertical bar chart that groups data based on values bins. For example, if we have people with 0 to 10 years, 10 to 20 years, 20 to 30 years, etc., etc., etc. And we don't have this type of chart here in CRM Analytics. But I could create a pseudo one. It's not a true histogram, but it's almost one. I'm going to show you why it's not a true histogram, because we can to see. And why this is important, Philip? Why is it's chart so important that we need to see a histogram scenario? Because the histogram chart, it's very useful to find the distribution of your data. If your data is skewed, if it's not skewed. For example, clearly my data is skewed. We see much more values here on the low. On the low, for example, we see much more values here from values to 1000 to 199, from 2000 to 99, etc. We see much more values on this side of the chart than on this right side, meaning that the data is skewed. And this understanding the data distribution of your data is very important at first. And here I inserted a parameter where we can select the bin value. How much do we want to insert in each bin? For example, it will be 1,000 by 1,000. We'll separate 1,000 to 2,000, 2,000 to 3,000, 3,000 to 4,000, etc., etc. Or we can increase our bin values, like 10,000. If we increase, or let me type, I think it's best if I type the value because it's easier. If we increase to 10,000, as you can see, here is 0 to 999, then 10,000 to 1999, etc., etc. Now the bin values have changed, and we can see depends on the distribution of the bin value that you want. You can assign a bin value based on what you want to see in this histogram chart, but it's very useful to see the actual distribution of your data. And how I was able to create a chart that even doesn't exist in CRMA. It's kind of complicated, and it's not very performatic at with, I don't know, data sets with more than 10 million rows. I have tested this in a query when I work with a client that has data sets with, I don't know, 500 million rows, and the query takes a while to run, especially with being with smaller values. But basically, we just get the division of the modulo. There's a formula here where we can in CRMA call the modulo that I utilize somewhere, that gets the result of the division of a value. If it's less than 1, means that this value is less than the value we are dividing by. And the value we are dividing by is the value of our bins. Or meaning that from 0 to 1, everything that falls within the bucket will be the 0 to 1, the size of our bin. And from 1 to 2, 2 to 3, 3 to 4, etc., etc., meaning that we just have to multiply the remainder of this division by the number of the bins we have to get our bin allocations. If we do by 10,000, like I did before, we will get the division of all the records that are lower than 10,000 up to 1. When it starts, when matches 1 and gets greater than 1, it will generate a new bin, and it will generate a new bin again, a new bin, etc., etc., etc. The problem is, and why this is not a real histogram, is because a histogram displays the bins regardless if the records have values or have not. And here, I, at least from as of now, I couldn't do anything about this in CRM Analytics. For example, do you see that we have these spaces right here? Those are our breaks because we don't have a division for this value right here. The previous value will be to for 149,999. So the next would be 150,000, right? But we don't have this value right here. We only have the next value that will be 151,000 to 151,999. So we skipped all of these values of beings, which would be present in a real histogram. But as of now, that's the best I could do to build a true histogram. And the second reason is that a histogram doesn't exist in CRM as of now, is because when we group by the beings, meaning that we are transforming a metric value. For example, everyone that has 0 to 10 years old, those are numbers. Those are metrics: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we cannot group by metrics here in CRM Analytics. We can just group by the dimensions or dates. So we need to first do this calculation and then transform here the result of this calculation into a string, so we can then group by that being value. This is the part of the query where I create the histogram, and this is the part of the query, this one, where I create the break values, the separation of the values within the when we have a skipped bin, when we don't have a value for the division. So I insert this break text and the number of the breaks. So I get break one, break two, break three, and a continuous value. It's not a perfect histogram again, but it is it's very useful if you guys want to utilize for the data visualization. And again, it's not very performatic with very, very, very huge data sets, but um I can share with you guys later. Everything I can share with you later. Okay. Another thing that is good to utilize the parameters of our queries. We know that we can filter data based on our security predicates on the data set. What do you mean by that, Philip? Check this out. This is a data mask dashboard that I created just for the purposes of showing row level access of data that we have in CRM Analytics. But this is a different step and a different process. For example, as you can see, I am Chris Cornell. I am logged as him. And logged as him, Chris Cornell can see his client's emails and his contact name. But since he's not the owner of Rihanna's contact, of he doesn't have access to Rihanna's contacts or Lady Gaga's or Phillips or etc. etc. He cannot see my emails or my contacts names. But the security predicate would definitely would be completely exclude these rows from our data set. He wouldn't, if I was logged as Chris Cornell, I wouldn't be even seeing the Lady Gaga row, this one right here, this one right here, etc., etc., etc. And sometimes depends on the client that we will work, depends of the business requirement. They don't want to restrict access to the data. They want everyone to see the full data, but don't see the name of email, of contacts, this kind of information. So I build this as an example of a possible data masking, if I may insert this way, that can be done easily within CRM analytics based on the logged user. If the user is logged Chris Cornell, he will see his data. If the user logged is Lady Gaga, the data changes. Lady Gaga can see these contacts, her contacts, and not anyone else's, and so on, so on, so on. And I built these two different charts because if you notice, especially here on the name, I have created a substring formula and a replace formula to replace the exact same characters, letters from the name and last name of the person, XXX, excluding the first letter. And in the second one, I created a simple case statement where I just replaced by the XXXXX, regardless of the name length, regardless of the character count of the name of the person. And why I do this? I wanted to show you guys the difference of performance that each one of these approaches take. Because this looks more beautiful and more professional, but is much more performance consuming. When I loaded a data set, the most that I could load, guys, was 200,000 lines, and this query took 5 times more than this query to run. Uh, so uh, I wanted to show that we also need to consider here in the dashboard inspector. By the way, the dashboard inspector is the best friend if you guys want to understand why your bindings, your interactions are not working, everything like that, etc. It's the you can see in the dashboard inspector, and you can see the performance of your queries, the total performance, the comparison one against the other. I am utilizing a data set with 1,000 rows, so the performance will be almost the same, right? But if we are dealing with millions and millions and millions of rows of data, this one starts becoming very, very heavy to load, while this one loads much more faster. Okay, and let's see how does this work behind the scenes. If we check here, we basically pass the values of the interaction, where it will be the logged user. If the owner equals the logged user, then results the email of the client. Else, then I do this whole formula right here to replace the email. It's a very huge formula that can be done with a simple that could be done with a simple case statement that I'm going to show you in the next table. Likewise, here below, how do I substitute the exact number of X characters by the exact count of each record of each character in the name and last name of the person. I utilize this formula right here that counts and utilizes a substring and replace to get the values uh, of the number of characters of the name, and then basically replacing the first and the second name by the access. Okay, which could be done almost like the same with this formula right here. Much simpler, much more performatic, but this doesn't take in consideration the length of the name that should be masked. Okay, it's just replaced by xxxx five or six x's, and the email likewise with the email xxx at xxx dot xxx, you know, but it's much more performatic. So the purpose of this one it was just to show you guys that sometimes we want to hide the data, but we don't want to hide. We only want to hide the details, not the whole row. Because if we insert this kind of data masking and data restriction within the security predicate, it would exclude the whole row of the data set from the users that don't have access to it. Okay, and how do you find the logged user? How do you know which user is logged? With this query right here directly to the user object. We can edit, and basically it's a simple query, the most simple of all. We get the ID and the name from the user where the ID equals to, and this gets the logged user ID. Simple as that. Okay, simple as that, guys. Then we pass this as a result binding to the both of our tables, Here I am utilizing instead of this the selector, so I can make it this dynamic. But if you guys want to make this filterable by the logged user, just replace the value, the result interaction of this query to the other two queries, and voila. Okay. But if you are interested, this is not a true data masking, it's just a replace. If you are interested in a true data masking example, there's a product from Salesforce called Salesforce Shield that truly masks and encrypts the the data within Salesforce and also within CRM Analytics that works with data encryption. Okay, it's a of course it's an extra license and will cost more. Okay, but this product exists in case you guys are interested. Okay, next chart. It's a chart that I don't see often being used, and I like this chart. I know that sometimes it can get messy, especially because of
Philip, sorry
go on.
to interrupt you. There are two questions for you that
Sure.
might help before you move on to Sankey.
Mhm.
First one is, can you put in a few words what is column map?
Column map is the instructions that create. Let me open here a query so you guys can see. There are instructions within. I have to create a query from. I think it's best if I show you guys contact, and let's show the count of rows. Yeah, I think it's okay. Here's a query. Let's open the query advanced properties. And if we search here, we have the column map component of our query. The column map are the instructions that will say this map will be grouped by this field and we will plot the aggregation of this field right here. You know, the dimension axis represents the groupings. We can have one or more groupings. For example, we can have contact, and below the contact we have account, and etc. etc. We can have from the user interface at least 10 groupings, if I'm not mistaken, from the compare table. And here we have also the metrics where you can aggregate more. Let's add one more metric so you guys can see. We edit. Do we have another metric? Let's get unique email. Yeah, we will have only one. And let's add another one like owner. We will have another one as well. But let's check now our column map right here. Now we have in the plot the same grouping that is contact, but now we have three different aggregations. First is letter A, second is letter B, third is letter C. Okay, as you can see, he doesn't label the columns as the name of the fields we are projecting. He labels as one A, B, or C. Okay, and you can check right here at the columns above that are being projected. We have the column, the name is A. We're naming this column A, and the field is the count of records of our data set by the grouping. Okay, everything that here takes the consideration the grouping that we are utilizing, which is the contact right here. The second metric is the unique emails that we have. We are labeling it or naming it B. And the third one is the unique owners, and we are naming it C. Okay, by our group contact. The group is contact. If I let's change the group, let's see if it changes. Edit. Oh, sorry. Let's open again. Lines 2. Edit. Let's switch to email. There you go. Now let's open our properties again. The group change. It's email now. Let's see in the column map. Oh, we also changed. It's email. Okay. That's the column map. That's what the column map does within the widget. Okay. Is it clear? Do you guys have another question regarding the column map? Did I explain it well?
Uh, Andres says column map often messes up when bindings are involved. Yes, that is very, very true. The way I go about it is, if I have column maps, I need the column maps in a certain way with bindings. I do not use compact form anymore. I turn it to SQL. That helps prevent column maps from breaking completely.
Exactly.
There's no other way of doing column maps if you have bindings involved and you don't want to break things. You have to go the SQL route in that case.
Precisely. You're
Also,
100% correct.
thank you. Mohammad Alam has a question. How feasible is this, as in your several charts? If we have dimensions and measures coming from different data sets.
It is still feasible because it doesn't matter. Because we suppose that you have data from 5 different data sets. We will group all the data sets based on a single field. Or if we are grouping by a single field, we will group all the 5 data sets by the same field. Or we will group all the five data sets by 2 fields, by the two fields that are the same, So it doesn't matter because in the final projection, we end up projecting the same number of groupings for all the data sets, regardless of the of which data sets we are utilizing. Let me show the query so you guys can understand better. For example, suppose that we have 3 data sets loading here instead of a single Q1, Q2, and Q3. We are grouping aviation data. Actually, let's add others data set. Let's add mask data. Let's add this one and this one right here. We have now Q1 is loading mask data. The Q2 is loading this one, and the Q3 is loading the snapshot. We have Q1, Q3, and Q1 and Q2 and Q3. Sorry. Then we are going to group Q, the first one, by account. The second one, we will group mask data by also account. It doesn't make sense if we are going to group different data sets by different columns, unless you want to make an append or something like that, or otherwise it doesn't make sense. Because when we are grouping, we are extracting the value of the data for that column, and all other fields are only going to be accessible by some kind of function. So the main idea of the grouping, as you can see, we will group by Q by this, then Q1 by a field that represents account in Q1, Q2 by a field that represents account in Q2, and so on, so on, so on, and so on. And then we will aggregate the sum of amount. We can do the calculation, like, for example, sum of Q amount times sum of mask data X divided by sum of third data set Y. But it will be projected as a single field. And this is the field that we are going to utilize to project our chart. So it doesn't matter if we're utilizing 1, 2, 3, 10 data sets, because what matters for this chart, for the end, is the final projection, how we are projecting our final projection. That's the part that matters, the grouping and the projection. Okay? As long as you consolidate all of our different data sets data into a single stream of projection, of grouping, you can do this with 1, 2, 3, 10 data sets. I don't know. I don't know if you can. I never loaded more than 5 data sets in the single query, so I don't even know if there's a limit for that. But that's it. That's how you do it. Any other question?
Yeah, Zach has done 9. I was thinking Zach has to do more. Also, Zach said, nicely done.
Yeah, much appreciated, Zach.
So those of you who don't know Zach Otero, and thank you for joining, Zach, he is the first golden hoodie recipient of
I was just talking about you at the beginning of this meeting about your Tableau Next.
Welcome, Zach.
I met Zach before he was a superstar.
Yeah.
Nice meeting you, Zach.
Yeah, you too.
Much appreciated. Much appreciated. I hope you are enjoying the event.
Yeah, that's a great presentation. I love SQL, so like you're joining multiple data sets into a single projection is, I do that for fun. So yeah, it's
exactly.
Do that for fun. Thanks.
Yeah.
Okay, back to you, Philip.
Okay, continuing the presentation, I was talking about the Sankey chart. That is a chart that I don't see very often utilized. uh, in I don't know any Salesforce dashboard, CRM Analytics dashboard that I worked. And just so you guys know, this chart doesn't even exist in Tableau. You have to install an external extension to have this chart visualization available in Tableau. I get that, and I get why people doesn't like sometimes Sankey chart, because in CRM Analytics it's kind of limited. As you can see, for example, we have I have grouped two sides by a different group type. I cannot group by the same. And I'm basically calculating the sum of amount that moves from one side to the other. For example, we have $30.5 million that belongs to the opportunity stage prospecting, and that our own opportunity type, which is the type? Existing customer replacement. And we can see the flow of data right here. And since a Sankey chart works dynamically based on the highest values to the lowest values, when you have very, very, very small values, as you can see here below the screen, it gets very difficult to interpret and to see the actual lines of the Sankey chart. And if we click edit right here, we don't have a conditional formatting to display each one of our groupings on the bars as different colors, so it would be easier to read, in my opinion. Of course, of course the colors change, but these colors are default for every group that you select. But if you insert the colors within our dataset XMD, then we can color code a Sankey chart, and which, in my opinion, is much more easier to interpret, because the we that work with business intelligence, it's not just about wrangling the data and preparing, etc. We have to be able to interpret what we are seeing, right? And so we need to set eyes on a chart and understand, oh, this is flowing from this to this, to close it. Oh, I see. Okay. And whatever you can do to make it easier for a person to be able to interpret the chart, the best and more the more adopted your dashboard and usability will be. Okay. And speaking of dataset XMD, if we select what is a dataset XMD, for example, if you select here, let's edit the dataset, we can see that we have this file right here. That is the dataset XMD. If we download it, we can edit, and after the event, I can share the documentation where you can find how to edit a dataset XMD, how to insert derived dimension values, derived dimension, conditional formatting, etc., etc., etc. And so you can utilize these, and your charts will have these colors by default. All of your charts, So this is very useful when you have, for example, a Sankey chart and you guys want to utilize. And in this case, another, in my personal opinion, I think this chart works very well with a snapshot, where you can see the previous stage of an opportunity and the next stage and the current stage. So if we could snapshot our opportunities data and start seeing, oh, the previous stage was what in analysis, but how many of that data flow to our closed loss stage? We have the value right here, and we can see for all for the greens would be the closed one, and in the qualification the open stages, and the closed loss in red, of course. But this would still not solve our problem for seeing those big values if we have very, very large values here above, and squeezed down here below very, very small values like we saw in the previous chart. But this option would fix that, where we would see not by amount anymore, but the percentage of records that change from one stage to another. because all the values would represent always 100% of our stages, 100%, 100%, 100% of our groupings. How many of our in-analysis opportunities upgraded, moved to a stage forward than upgrade? 55.99%. For qualification, the same thing, 31.06%. You know, and this makes the Sankey chart interpretability much easier, because now we don't have to worry about the length of the squeeze of the small values and the difference in the scale, because they will always have the same scale, 100%. And we can even filter the to see, oh, let's see from previous stage in analysis, how much 55% to upgrade, lost 36.77, etc., etc. And we can even insert below here a detailed table. When we click the Sankey chart, we would see the names of each one of the rows of the opportunities, with the names, the amount, etc., etc., that change from one stage to another upgrade. How many we lost from this stage and why we lost them. This is the first stage, and from the first stage we already lost them. Is it a great percentage? Is it a small percentage compared? We can search for this. Oh, the biggest percentage of lost is on the analysis that, if I'm not mistaken, is the first stage. Okay, and then we have the second in qualification. We have some that are losing here in negotiation. Okay, and we have even some opportunities that are downgrading. There are entering a stage that was behind the current stage. So why this is happening? Is this are these openings being pushed? Do we have a problem with our negotiation process? How many? Most of the opportunities are here on the negotiation, meaning that we can review our negotiation process. Is it very tight? Is it very complicated? Are we charging the prices are too high? How can we review this so the in negotiation opportunities starts going more to the upgrade than from the downgrade, you know? And these are the opportunities that are stalled since the last snapshot date. We can see that we had no change from these stages. They remain in this stage since the last snapshot date. So this is a very useful usability of the Sankey chart. And it's a simple grouping query. I didn't do any complicated query on this one because the catch of this presentation is not on the query or on the chart, but in the XMD of the dataset, because we cannot conditional format the Sankey chart, but we can conditional format the XMD of the dataset, making it custom colored. Okay.
So, Philip, you might have to explain the XMD because Anders is asking about was it JSON or XMD where you did this?
Okay, let me see the accurate data set just to make sure. Is it the snapshot data set? Okay. Snappy. Osh. Did I read it wrong? Snapshot? No, I didn't. Maybe it's capital. It's. Oh, come on, guys! Don't do this. Don't do this to me. Oh, there it is. Here, the snapshot data set. Let me open the XMD for you guys. Download it. Let's open. Here, as you can see, is the dataset XMD file. And as you can see right here in the derived measures, we have the conditional formatting, the name percent of the field, the custom format that I inserted right here with a percentage. The multiplier is 100 because a percentage is always multiplied by 100, right? We can see, and here you can see the previous stage colors and the current stage colors. If you check right here, where's the conditional formatting? Here, conditional formatting, the chart colors, I get the value in analysis and the color the hexadecimal color for this value. And then we insert each one of these right here. And the reference field, which one is the previous stage, meaning that for the previous stage, all these values right here that we have before will be colored like this. This one will be this color. This one will be this color, and so on. Okay. And I did the same, of course, for the current stage and from the custom fields that we create. The difference is, as you can see, we have derived measures and derived dimensions. I did this on the derived measures because we're talking about measures, but we can do also on the derived dimensions when you're talking about dimensions. Okay. And then once you download it, you edit it, and then you just upload again right here, click replace, and voila, your data set is ready with this new XMD file, color coded, and this will be updated in our dashboards that utilize this data set, all of them. So before actually messing up not messing up, sorry, playing with the dataset XMD, make sure that our dashboards really will utilize and be standardized with that formats. Okay.
Is there any better way to do this rather than coming to this JSON file? And
there is, but for that particular chart, no. But there is for other charts. For example, let's create with the same data set. Let's change category right here. Sum of amount. There you go. And let's sort it descent. Okay. For a bar chart right here, we have the conditional formatting right here, where you can select the change category and color code each one of them as you please, or you can select the measures and make the sum of amount this color, or you can make it black, you can make it white, or you can make like a gradient. Sorry, for example, the low color is red, and the high color should be green. You can create a gradient scale based on your sum of amount.
I think what I was asking is, if you do this, right, this coloring has to be done by widget or dashboard by dashboard.
No. If you do this here, what I am doing, you have to. This will be for this single chart right here. This won't be applied if you have to reutilize this with these colors in a different dashboard. You have to do this again in the dashboard. But if you do this in the XMD, all the dashboards that utilize this metric like this will already be formatted with this conditional formatting that we applied right here. That's the advantage also of utilizing the dataset XMD, because this makes all the dashboards that utilize that XMD with the colors that you insert there, instead of having to create the same chart again as etc., and formatting it, etc., again.
So let me ask you. Let me explain. Right. Sometimes, so if you can go to the data set view, please, if you don't mind.
Sure.
Go to the data set. Not here, just like the data set in your.
This one.
Yeah, here. Yeah, here. If you explore.
You mean by here?
Yeah, here. How does this help? And this is something which is a very powerful feature. Maybe you can talk a bit about where you can
Sure.
save it here, and for everybody all the dashboards can use this, right?
Yes. This is what we are doing here. What's your name, please?
Krishna.
Krishna, what Krishna mentioned is that this is the data set XMD, what we are seeing right here, and there is an easier way to do this. But the problem with this right here is that at least I never could edit the derived measures and the derived dimensions right here. I never could, never, not even once. I only could edit the default fields that come from the dataset. What is a derived dimension? What is a derived measure? Those are fields that you create within the query. This field doesn't exist in the data set. For example, you can multiply this amount by 10 and divide by 100. I don't care. And create a new field. And then in the XMD, you can add as a derived measure. but Philip, never was able to edit the XMD of derived measures here, only the fixed ones. But like Krishna mentioned, if we click here, we can edit the change category to just category. Here we are not changing the name of the field. The field continues being named change category, but the label of the field now changed to just category. So we are editing the label of the field right here. And if we click here, edit values, you can edit the color of our values, as you guys can see. And even the label of the values, instead of downgrade, we can call it ABCDE, and save it. And that would also edit the dataset XMD. This is much easier than edit the JSON file. But like I said, I always had problems editing the derived measures and derived dimensions, especially when working with custom created fields. Because this one, the percentage one, although this is this is a grouping, so this field was created on the recipe. That's not a good example, but all of the fields that I have to utilize in the data set that require or a derived dimension or a derived measure, I never was able to edit the XMD through here, only through the code. And this is why I'm showing how can you do this. But if you want to do this to a field that's not a derived dimension, you can utilize this method just like Christian mentioned. Just click, go to the dataset edit page, click explore, show field panels on this drop down right here. And then you can select the field and change the label. If you click here, you change the label, or in the drop down arrow, edit the values. Okay? Anyone else have? Go on. Anyone else? Questions?
I think there was a feature where we could set up the primary colors for the bars and things like that, right? Was that in the template? So it will automatically, like if I drag and drop the bar chart, it should automatically pick up what I define in my template, what should be my primary color and the next color, especially in stack bar or the other stuff.
I'm not aware of it. The only place that I know that you can do this is here in the XMT, but not from the chart. Maybe you're talking about the data, the dashboard XMD, but it's, for example, when we create a dashboard and this form, suppose that I have created several charts here with different.
But then I think there is a place where you could define what should be my primary color for my entire CRM. Like if I can drag drop any chart, then it should be using the theme colors which you define there, so you can customize the theme.
That's dashboard themes. That's a different thing than the data set. But can we let Philip finish his presentation and then go to the asking questions, please? Thank you.
Thank you, guys. Now I'm going to show you the comparison dashboard that is basically a simple comparison of metrics where we can select our groupings and the number of groupings that we want compare against the total of the groupings in the data set. For example, here we have our accounts and we are grouping 2 accounts and we have the total remaining records here in the same bar chart. And these 2 top accounts represent 1.9 million of our total. And the rest of the total is 3.5. If we increase the groupings, we have one grouping, the third one is the Lockheed Martin, and all these 3 combined represents 2.8 million, and etc., 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 and so on. As you can see, it stopped at 8 because we don't have any more values within our accounts. So it doesn't matter if I insert more groupings, it wouldn't change the dashboard, this visualization, because I reached all the total values of our groupings, and we have the total bar here below displaying the sum of everything. Okay, but we can change also to owner, for example, and start stacking again. Jisoo, Hazel Scott, Rose, and Ariana Grande, and Will I Am. All of them have third 3.391 million US dollars, representing 62% of our total. Just these five guys. If we get only the first four, we get 54%, meaning that these sellers right here represents 54% of our revenue. Those are the best sellers. Okay. Let's get the top 10. The top 10 represent 5.1 million records, 94%, 94.7% of the total. Okay. So the idea of this dashboard is just to compare the visualization in a single bar chart instead of creating a big number to show totals and etc. Sometimes you may want to see, oh, how is my top 5, and I want all the others in here below, without stacking. I just want my top 5 and now the rest combined here in a table below. How can we do this? If we select here in the explore mode, we can see that we have the closed one, and right here we can utilize the offset and the limit functions to restrict and allow the visibility of the rows. That's how I change what is being displayed on the dashboard. By limiting the number of the rows in this grouping, we will get only the 5 first, since we are sorting here by the sum of amount descending. We will get the first 5 with the highest amounts, and the offset is the opposite. The offset, you sort your data by disorder, and then get 1, 2, 3, 4, 5. From the 6th and beyond, it will get the list of the persons. So that's how we separate the top 5 from the rest. We get the top 5 with this limit, and then we offset all the rest with the total, and then we subtract one amount for the other to get our stacked bar charts that represent the sum of these totals and the sum of the rest, the sum of the top n or the rest. And it's a good way to do a comparison. Sometimes your chart may become very very low compared with the total amount, because we may have billions and billions of dollars and small values per grouping. So this bar may become very very big compared to the other bars. And one thing to work around this is to utilize the logarithm scale, for which I will show you a different example as well, where we can see the aggregations of the bars, but the scale of the bar is always will always be visible, because we are utilizing the logarithm. So it doesn't matter how big this bar below is. In the with the logarithm scale, we will still be able to see the smaller bars above. Okay. This is another visualization of an example of a data set that has 6 metrics that I converted, I pivoted into columns. So I transform all of these metrics into groupings, basically, and aggregated them into a single stacked bar. This data set is comprised of a single student name and 5 columns with the name of his grades on each one of the subjects: English, math, geography, etc., etc. And what I did here, basically, I aggregated and separated each of the of the metrics in a single variable and with a single grouping. I created a grouping here. We are creating this sum of English and English as subject, and the same for math, the same for geography, etc., etc. And then we union all of this data by appending. A union is nothing more than an append, and then we group by the student and the subject, because this will make our bars stack one by each subject, and then we can color code like we did, utilizing here different colors for our subjects. And we can either see the biggest or the smallest student for each one of our subjects. For example, who has the highest social studies? The best student of all is Maisie with the overall grades. But let's see who is best in social studies. Hope. Or in math. Now we're seeing math and social studies, but let's see just math or just geography. Okay. And we can limit this chart because, as you can see, this is a very, very huge data set with more than 1,000 names of students. And one thing I left this way because, like I mentioned before, a big difference and the main concept that you have to keep in mind when working business intelligence is the interpretability of the data. How easy is for me to interpret what I am seeing? For example, it doesn't matter. I left it this way, and the people has to scroll. This is a pain, and it sucks. I know, but if I inserted like this, it would be. How can you interpret a chart like this? It's impossible. Looks like it looks beautiful and fun for the presentation that we are doing, but you cannot interpret at all. I don't see what I'm seeing. I'm just seeing some crazy mesh of data, I cannot interpret. I have to hover the bar and see the name of the student for this single subject. So this is why I left this way. But there are better ways for to present than these stacked bar charts to present the comparison against the metrics like the one I did, like this, which is, in my opinion, a chart that is also not very utilized here in CRM Analytics. That is the metric radar chart that displays the comparison of metrics one against the other by the groupings. Here you can see that we can, but these charts also represents problems of interpretability, because the more groupings we insert, the harder it gets to interpret and understand which one belongs to which. I know, I don't know you guys, but I already lost. I cannot understand who is who. I cannot, and you cannot even hover some of the areas of the metric radar chart. So, in my opinion, this is a chart that has to be utilized, but has to be utilized with caution. A comparison against three at most, to compare the notes and see how is one area, one student is doing against the other, etc., etc. And for example, we can see by the top of history note, or the students with top social studies note, of the top 3 geography students, but the metric radar chart is kind of complicated to utilize, because if we create a query from straight on, let's be the sum of amount. Oh, I only have 2 metrics here. I have to utilize let's do the student data. If I aggregate like sum of English, sum of geography, sum of history, and I utilize a metric radar chart, and I forgot the student, sorry. As you can see, we have the top, the 10, but the metric radar chart always go to the max. Let me limit by tree. The metric radar chart only goes to the highest point of the grouping we are seeing. The highest point is 10. We know that the biggest grade is 10, but we are seeing only up to 7.9 here, because that's the highest within all of the top three groupings, and this messes up our scale. Our scale, it doesn't work very well if you don't have a fixed scale, in my opinion. So that's what I did on the split metric radar chart, where I created a phantom group. This is a phantom chart, as you can see, with the top 10, the maximum of the values. So when we select the students, we can compare accurately against the other in the same scale, because that's what matters. We need to we're talking about interpretability again. So we have to have an idea based on the same scale, right? And the scale is fixed for this one, making the metric radar chart much more interpretable, in my opinion, of course. Let's go to the cohort analysis. The cohort analysis is a cool one because, just like the histogram, we converted an axis from number to string to summarize it and group it, because we cannot group data by metrics in CRM Analytics, only by dates or by dimensions. Okay. And what is a cohort analysis? Basically, it's how often how long did our customers took to purchase from us again since the first purchases. Okay. So we get here, for example, for the client cookie, the first purchase was January 2020, and the second purchase was 6 months later at July. But the next purchase was only 27 months later in 2022. So what could happen that this guy could be the pandemics? I'm utilizing all fake data, okay, guys? So don't bother. This is random data, but could be the pandemics. What the purpose of this chart is understand the buying behavior of our customers, and how often they buy, how often they purchase from us since the first purchase. Okay. And I am color coding here based on the previous value, always utilizing something that we call windowing functions that we will see in this dashboard right here, where we compare from the previous purchase if the next purchase was lower or higher in amount. If it's lower, it will become more red. If it's higher, it will become more green. So we can understand, for example, here, do we have a trend of increase, decrease of purchase from a client? Is he buying more? Is he buying less? Is he buying more often or less often? And we can also here we are seeing relative to the first company, to the first purchase date of the company. For example, 2020 January, 2020 February, etc., etc., etc. But we can see relative to the first one up from the first customer, like this. So in 2020, the first customer purchase are these ones that purchased in January. Then these ones purchased 1 month later, February. And then we have these ones. And then 2021, these ones, 22, and this one is 2022. This is a heat map chart, by the way. This is the one that I was going to talk about, the heat map chart that displays in color coding the visualization based on if we have records for both of the groupings or not. And the more we have, the brighter the color would be. But here I am utilizing to create a cohort analysis. Okay. And here we are only seeing the difference values from the previous value, But if you get the difference from the total average, from the total purchase of this of the single customer of the dates, uh, which ones were above the average or below the average? Do we have some spikes? We can check that like this. Oh, and we do have some spikes. Like for example, this marshmallow customer right here. At this date, 2021 July, he purchased much more than the average. As you can see, it's really bright green here. What happened this date? So he could buy this. Why did he spend that amount this date? Was he robbed and someone utilized his credit card, or was him? I don't know. Um, he felt like he was spending. We don't know. That's the type of thing that the data analysis is cool about, to investigate and understand. Oh, we have this data right here and this one right here. Why these bright greens? Oh, those are the highest above the average. Why this date is important to show uh, why did he spend or spend more than the average on this particular date? We can start asking these questions, and this is very cool. So this is just an example of how can you utilize color coding and different types of color coding based on previous value, or based on the difference from average. So to try to find big data or outliers. We can also we'll talk about outliers in our next presentation right here in the quadrant chart. But just so you guys understand, this is one of my favorite charts, the scatter plot one, where you can see basically the is a grouping and two metrics that we are seeing right here. The plotting of two metrics, one against the other, the scores of the opportunities and the amounts that we have. And by utilizing the reference lines on both of our axes, we have two axes, axis Y and axis X. If we set straight in the middle a reference line here and then here, we can separate our chart in 4 quadrants. The money baby, woo, money baby, where we have the best amounts with also the best scores. Those are the opportunities that we need to understand how to replicate to our other opportunities, or the sales pitch, or the customer. We need to understand how we can get more of this. And are the opportunities that, oh, yeah, if this could improve, it would be nice. That are we have a huge amount, but the scores are not great. We don't always close with these customers, these opportunities. They're not all very okay deals. These are the ones that it is what it is, because we have good scores, but the amount's not that great like these ones. And of course, the worst deals in the history of mankind, where you can see. And how do you segment your chart like this? It's simple, by inserting a binding from this query to itself, but from this query attribute to the widget attribute, where you get the maximum value from our X chart and divided by 2. The maximum value divided by 2 will always be the half, because we have no negative values in the x-axis, and in the y-axis we have no negative values here. So we know that we can get the highest value and divided by 2. Okay, and that's what I did. I basically got the highest value from the x-axis divided by 2 and inserted on our reference line binding, and I did the same on the on the y-axis. If we see right here, we have the click x-axis, we have the binding on the reference line. This is an interaction created on the reference line. The same for the y-axis we have right here. Simple as that. And of course, when you filter, since it's tracking the maximum value, it will track, and the reference lines will always follow and be dynamically allocated within the values that you insert. Always. I wanted to talk about as well how do we sometimes we work with very skilled data, and it's hard to interpret, especially because of the outliers. As you can see, it's very easy to track outliers in a scatter plot chart. As you can see, because we have most of our data is right here, and we have these guys, these 4 guys over here, and they are pushing the scale of our chart above, you know, and it's very difficult to interpret the great mass, because I think more than 90% of our data is here, and these 4 records are messing up the scale and make it hard to interpret. So we can try some kind of normalizations and data manipulations to try to improve the visibility, like the min max standardization, where we don't utilize anymore the values on the x-axis, but you get the maximum value would be 100 and the minimum value would be 0. So we will compress everything in scale from 0 to 1, all of our values. But as you can see, this doesn't change the distribution of the data. It changes the scale. It standardizes the scale, but it doesn't change the distribution. We're still seeing it's still very hard to interpret this side of the data, like here. And we can try the min max minus 1 plus 1. It's the same of the min max. That doesn't change the distribution. It's still the same problem. But now we have the maximum value is plus 1, and where it would be the 0 is negative 1, and the 0 is the middle. But it also doesn't solve our problem. So we can do the comparison against the average, where the average is 0, and now we are seeing how far from the average we are. Okay, well, the percentage this is basically the sum of the value divided by the average, where the average would be the 0, right? And now we have the mirroring the reference lines, where you can straight up is just like the min max standardization, but instead of standardization the values, now we are just passing these values to the reference lines. So we get the maximum value one and insert a reference line for the maximum, and get the negative value, the same negative value, and insert a reference line for that, inserting our records here at the middle. This makes but none of this solved our problem so far. The interpretability is still bad. We still have the outliers right here, and we cannot understand well this data. We can utilize even the z-score standardization, where now we are seeing the distribution of our data based on the average, like here, but differently. We are seeing how many standard deviations our data points are from the average. So this one is almost for the standard deviations away from our average. The 0 is the average, okay? And finally, we can get the method that works more, that is excluding our outliers. How do we exclude our outliers? Here we are talking about extreme outliers, but everything that's greater than 3 or less than 3 standard deviations from the mean are considered outliers. So we will exclude these records. If we exclude them, now we can see much more distributed and interpret a little bit more our chart, because we have excluded the outliers from our data points. And this is the main records that we have. It's not that the outliers doesn't matter, but we have to keep in mind that this is the vast majority. So we have to keep an eye on the vast majority and keep a separated eye on the outliers, okay? And this is the best way to do this, by eliminating the outliers from our data. And we utilize this by doing the z-score standardization and then excluding and then you can select how many standard deviations you want to exclude above or below your chart. It doesn't matter. And one thing that I started playing with let me change to all time here, with the scatter plot chart, is the diverging color palettes, where we can, if we can play with the axis and make the normalizations and standardizations, making the zero here for both of our axes at the middle, we can make a diverging increasing color palette on the sides, or a centralized color palette in the middle, where everything in the middle would be bad and everything outside the middle would be good, you know. And this is a different type of visualizations, where you want to maintain, or you can do the reverse. Everything near the center would be green and big, and everything on the outer bounds would be red and bad, you know. So this is the idea and concept between the min max. This is how I built a chart like this. With the, if you create the min max and standardize your axes, then you can do these kinds of stuff, like the waves. This one is nothing more like than the getting the modulo function and getting the remainder of the division. If it's, for example, here we are dividing by 5, so we get, this is what we get is values. We get everything that's divided by 5 and starts getting more red, or until gets I think it's not by 5, maybe it's by 10. I don't remember exactly the number that I was dividing, but it's a wave chart that sometimes we may want within some certain range, but passing this range would be bad, you know, something like that. But for each one of our axes and our data points, so it's a type of visualization that you guys can also utilize sometimes, or not, you know. Is the purpose of this part is just to show that it's possible, and kind of like more an artistic view. Like, for example, the one that I mentioned, that you have everything in the center is good, and the outside data points are bad, and vice versa. Everything in the center is bad and the outer data points is good, you know. We have the increase also, where everything that's higher gets more bright and big, and everything that's lower on both axes is bad, you know. So that region would be the good region, the money baby region, where we are that we already seen. We can create the bullseye, a scatter plot, showing, basically filtering out all of the values that are outside the center of the range. So we can get basically utilizing the radius of the circle, and if it's bigger than the radius but less than this, and creating intervals that will be filtered out of the final data set, displaying a bullseye, you know, or a spiral, utilizing the sine cosine formulas like this, or even the country of your the flag of your country, in this case Brazil. Okay, where you can calculate from the center the radius of the circle, the area of this diamond, you know, and everything outside that would be the green. That's how you calculate it, by maintaining your normalizing or standardizing your values to the center, and measuring from the center. Okay. Now we talk a little about windowing functions. We have one more to go. That's the final GeoJSON. But I'd like to show you the Pareto chart that's very utilizing Six Sigma. What's the name? Six Sigma. It's kind of a process. It's a process called Six Sigma that they utilize the Pareto chart to verify the 20% that generates the 80% of result. It's to try to illustrate the Pareto principle. That we will not see this in this fake data, but it's I inserted here 2 reference lines, as you can see, so we can measure and compare how much percent of the cumulative from the first to 100% each bar corresponds. And we can see, for example, Embraer for itself corresponds to 18.9%. These ones alone correspond to 16.41 and both 35%. So this would already be our 20%. Okay. And we can see like this the cumulative distribution, where you can see by amount or number of opportunities. And if you change, you can notice that the account with greater of opportunities, with greatest opportunity amounts, is not the one with the highest amount of highest number of opportunities, meaning that the average amount of opportunity is higher for this company than from this one. So this type of analysis is very cool in my opinion, you know. And you can change, of course, to see by opportunity owner and by type. And this chart can only be done by windowing functions, guys. What is a windowing function? Let's open the query right here. It's a function that looks into different rows of the same column. For example, this one right here, it's a windowing function. Oh, this part right here. What is this doing? First of all, remember, windowing functions are only function when we are grouping by. You have to group by to utilize a window function. You can utilize a window function without utilizing SQL query. But for this particular chart, we can only do utilizing SQL query. Why? Because we have to do two windowing functions into different groupings. And we have to regroup our data again after to generate the second window function. If I delete this line right here and run, it won't allow me to run the second window function because the data is not grouped anymore. I have to regroup the data again to generate. And why do I have to generate two window functions? First of all, to find the percentage of the total. This one is to sum all of these amounts right here by the groupings. So I am summing this with this, with this, with this, and getting this total into a single column. And then I am dividing each one of the individual values, the sum of amount, this individual sum of amount, by the total that we calculated to get a percentage, right? And then in the second window function, I am aggregating all up to the current row from the percentages. So that's how we get, for example, the cumulative is 0.24 is the first. The second one is this plus this. The third one is this plus this plus this. Fourth one, this plus this plus this plus this. And the fifth one is the last one. Okay? This chart is only, and that's why I want to present this chart. I have a blog post in Rick's blog I can share after the event, but how to create exactly this chart and why is only possible to create it with a window function. Window functions is also good to create a goal attainment line chart. This was not even an idea of mine. This was an idea that I implemented for a customer of mine, where he wanted to see the goals lines cumulated by the period. The green line would be the amount they attained, the one amount, and the red line would be the difference between the green and this minus this. And I find, it's an interesting way of measuring your goals, because you can start like, for example, let's say current fiscal year today, and it cumulates, you know, and we don't even have to have our each one of our data points, because here, as you can see, we're accumulating by day. But there's a function in CRM Analytics called fill. If I open here, we can fill our dates based on the on the dates that we want to insert. Meaning, for example, this part right here, that's the part where we get all of our goals and filling all the gaps of values that we don't have in the middle. For example, oh, we only have close date for this for day 3, then for day 11, then for day 2. Doesn't matter. All it will fill with all the dates missing the in the column, and the remaining values will be left null. But then by utilizing window function again, we can replace those null values with the values that we have cumulated up to now, like this, cumulating. And if the value is 0, is null, we can just aggregate the null values, and that's what we do with the green line right here. If we haven't won nothing here, 0, 0, 0, 0, then we won here, and we won here again, and we won here, it's cumulated. But now we don't want anymore, so it aggregates 0 and 0. Oh, we won again, so it's cumulated, and so on, so on, so on. And the bar starts trying to catch the goal, if you know what I mean. And we can even switch from territory. For example, let's see only by Argentina. We don't have for this fiscal year to date for Argentina. Let's see Brazil. Brazil, we only have for this particular date right here. We start winning opportunities. Okay, but let's see by owner then. If we switch by owner, you can I switch the data set that's being loaded to the goal date by owner and the grouping as well. Here we are now seeing owners, not countries anymore. For example, I see by Ariana Grande, we don't have nothing. Let's see Bruce Dickinson, nothing as well. Dexter Holland. Oh, for Dexter we have a big win here and a big win here as well. It's just a different way to represent a visualization of goal attainment. That's something that's also subjective to the person. Some persons will prefer to see, oh, I think it would be easier for me to see this type of data in this type of way. For example, let's generate the same one amount in a waterfall chart, like here. As you can see, it's the same chart that we are seeing right here with the line in green, only in green, but now as a waterfall. I have utilized the fill, and now we can see that, oh, we won here, here, and here, and all the other values remain null, and we only see our ones by date, right? And of course the total up to current fiscal year to date. Let's see it for the whole current fiscal year. Okay, let's go back to date. But we may want to see by certain kind of grouping. The waterfall chart allows you to insert a grouping. So we can utilize by owner, for example, where you can see and stack the bars. Once you have a one plus more than one user, it stacks the bar for each one of the owners, like this, and by type or country. As you can see, most of the opportunity ones are from China. But we can also see a cumulative view of this. Like I said, it's just a matter of perspective. Which visualization do you think it's more effective? This one's a little bit cleaner, but if we select the whole fiscal year, it starts getting difficult to interpret. But what if we utilize this one, a cumulative view that shows like this, where you can, it's not as clean as the other because we are seeing the stacked bars, but now we have we know how each month progressed and how much we have for each month, not just the final total. And we select the total of current fiscal year. Look how the interpretability starts getting harder to interpret, but it is still understandable, especially because of this. You may be asking, Philip, why didn't you insert the green bars at the top here and not below? Because the accumulated amount was already 1, and what we won this month, it's new, so it should be above, right? But that's the catch, guys. If when we are utilizing a stacked bar chart like this, if as the amount starts getting very, very high and the bar starts getting very high, the green bar at the top would be so small that we would not be able to see anymore as it starts to accumulate. But if we maintain the green bar in the below the gray one and utilize a logarithm scale, you don't have to worry about this. You will always be able to see the green bar because of the logarithm scale, and it's below because the logarithm scale only shrinks as it goes above, not below. So this is why I left the green bars below, so it wouldn't mess up the visualizations for our logarithm scale. But in my opinion, the best of these three views is this one. I don't know if you guys which one you guys prefer. It's just an example again. And if you guys have another example of goal attainment view, please feel free to share. I'll be more than happy. And one of the last things that I'd like to show you is the compound interest calculator. And the greatest part of this compound interest calculator is that you don't have to have a data set to create it. I mean, you have, but it can be any data set. Doesn't matter which data it has. Doesn't matter if you have date fields. Doesn't matter. It doesn't matter because I didn't utilize the data set's data to create this. I only utilized to load the data set and generate a query. Let's talk about Sayantani. She works very hard every year. And last year she was able to save $50,000. And Sayatani is a smart woman. She's thinking about her retirement, and she wants to retire with a good money. So she's reading about investment, but she wants to understand how much she would make with this amount by, let's say, 50% yearly interest rate for a period of, let's say, 10 years. That's how much Sayantani would make. 100 and almost $200,000. But just by leaving the money. Well, what about for 20 years? Almost $1 million with a 15% yearly interest rate. Let's see for 30 years. Not bad, huh? $3.2 million. Almost $3.3 billion. Simply by leaving our money with an interest rate. But suppose that Sayantani wants to retire earlier. So she starts saving each month $1,200. Now we can calculate the compound interest of her initial contributions plus the monthly contributions with the same interest rate. And you can see at the end, we have $500,000. Let's see, for the same 30 years, she would have almost $10 million. And she would be gaining each month $100,000 of interest, just of interest. At the end, of course, at the end of the period, not here in the start. And we can also see this cumulated, which corresponds to the contributions and which corresponds to the interest based on the initial amount. We can split by the colors, like I said, because the stacked waterfall chart doesn't have also conditional formatting. So we have to insert within the XMD of the data set like we did for the colors to track our interest calculations versus our monthly contributions plus the interest. Let's see how we calculated this. like I said, you don't need a data set with data at all. I just get the start date from now. Of course, suppose that she's in the bank, and the manager says, well, if you start investing today, so we get now, and then we utilize the fill. And the fill parameter allows us to insert a start date and an end date. So I inserted an end date of 3,000 years. Sorry, 1,000 years more than today. And but we don't have, because we will limit these query results based on the other parameters that we are selecting right here. So we don't even need the data in the data set. We just need to do the calculations based on the parameters we insert on these input widgets right here. Okay, pretty cool, huh? And of course, a CRM Analytics presentation, the last for the best, is not anything without custom GeoJSON files. You can create map charts within Salesforce CRM Analytics, but you need to utilize the custom GeoJSON files to do so. And to do so, you need, for example, to load the data that has to be a certain format and with certain IDs within the map in CRM Analytics. Okay, but as you can see, it works perfectly. This is Brazil's map separated by state, each state. And if we want to drill down, we can even insert the state map dynamically based on the selection, like this. And we can see the states with highest amount, lowest amount. Here are separated by on a gradient scale versus a beam scale. State of Bahia. And this is me right here, São Paulo. This is where I live. I'm somewhere around here. And as you can see, I inserted here on the tooltip a table that we can see the. I need to increase the tooltip. Let me do so. Give me a second. I think it's better. Best to 1,000 pixels. Let me see. I inserted on the tooltip a table view so we could see the details of the opportunities. So that's one thing that I try to always talk in my presentation, guys. Utilize the tooltip wisely, because you can insert a big visualization or a big chart within your tooltip to drill down, instead of inserting a new component, a new chart, a new visualization in your dashboard, so the user don't have to scroll up, scroll down, sideways, etc., to see the data points. The dashboard should be clean. The user should be easy for the user to find the information that he or she is searching very fast. You know, that's the main purpose of the dashboard. So the tooltip allows this much easier. If we filter and select the state, and now we have, oh, this is the only opportunity lost, and it's color coded because it's lost. Let's see the other city. This is one, it's green, cool. Is this, and this one, this is open, it's blue. Okay, and this is uploaded via custom GeoJSON files and bindings, where I can change the map that I am utilizing based on the state selected. Okay, here another example of custom Brazil exports, where I loaded the world map, but instead of creating a GeoJSON file where the boundaries would be the state, the countries, I created a JSON map where the boundaries would be the exportation routes, where you can get from Cuiabá in Brazil. It's a city in the state called Mato Grosso, and we export. And here in the tooltip, first of all, this visualization is a little difficult to understand, so let's zoom a little bit. Okay, we can search and hover the bar to see the destination city and the products that are exported: soybeans, iron ore, etc., and the amount in billions of dollars. In green, in the most green would be the the highest amount, and the red will be the lowest. For example, Mumbai is one of the lowest amounts, where Brazil exports crude petroleum, sugar, and soybeans. But from Shanghai, for Shanghai, sorry, Brazil export is the highest amount. That is also soybeans, crude petroleum, and iron ore, but it's the highest amount. China is Brazil's greatest commercial partner in the world as of today, and I created this to bring the top 10 commercial partners from Brazil, where we could check the different products that are being exported from Brazil to other routes. Okay, this is the Great Wall of China, guys, where you can see China, the country, and I got a GeoJSON file from a it was a GitHub. I don't remember the page, but it is the GeoJSON for the Great Wall of China for segment and period of construction. You can see several different periods of constructions and segments, because looks like there were it's very, very old, first of all, and there was wars, and some places of the Great Wall were originally destroyed and had to be rebuilt later for other dynasties. So I created in the tooltip the segment of the Great Wall, the dynasty that started constructing, and the year where the construction started. As you can see, this, and this. And as you guys can see, it's very, very, very huge. And again, we had several different constructions, several different segments of it were destroyed and reconstructed and destroyed again, because of the main purpose of the wall, that was to protect China's territory from I think was from Mongolia at the time. I'm not sure I don't remember exactly the people that they were trying to protect China from, but that's it. And the last one are the great wonders of the world. In this one, I didn't utilize a custom GeoJSON map, meaning that you don't have to necessarily upload a custom GeoJSON map file to create a custom map, because this one, it's a map from Salesforce that utilizes latitude and longitude to create. And here, again, we have our 7 wonders, where you can see, and you can even insert a GIF, the Great Wall of China, the area of construction, and the people who constructed it. From our friends from India that are sleeping right now, the Taj Mahal, built by Shah Jahan. We have the pyramids, which are not in the list of the 7 wonders of the world anymore, but it's a honorary wonder, because in my opinion, there are no wonder that compares to the pyramids, because they're so beautiful and so antique that they should be considered forever. But they are not officially on the list, but they were considered honorary wonder. We have the Coliseum, Petra in Jordan, must be such a beautiful view. We have the Christ the Redeemer here in Brazil, Rio de Janeiro, very close to me, not so close, but very close. We have Machu Picchu in Peru. And last, we have Chichen Itza in Mexico, the Aztec pyramid, that must be as beautiful as the Egyptian pyramids. I hope you guys enjoyed this presentation. It was took me a while to assemble it, but I think I covered most of the advanced stuff I know to do with CRM Analytics. And if you have any questions, let's do it.
Thank you, Philip. This was amazing, amazing. So, not too many questions, but even we learned something, right, Jen?
It makes me kind of jealous that I'm not entirely working in CRM anymore. It makes me like so bad, especially seeing your maps. Like when I used to spend months in making maps in there with all the GeoJSON.
Yeah, when he was showing maps, I was like, "This is Jen's field."
I know.
Okay,
Man, it was so difficult to create the line map. You guys have no idea, but it took me. But you know,
You
it worked.
upload the custom maps, and then you make a data set of the IDs of the custom maps you put in. Then you have to put that back into your data flow.
Correct.
Exactly.
That's exactly why I don't do custom maps. I'm not spending all my hours doing custom maps for.
I've been there. I've done that.
Okay.
Yeah.
So here are the last few questions for you. I'm going to share the recording. So everyone asking about the recording, yes, it is going to be shared. Give me a couple of days, but I will share the recording, maybe over the weekend. I have been asked by now 3 or 4 times about the JSON XMD files that you are working on.
Mm-hmm.
If they can be shared.
What's the... if they can be shared, yes, I can. I can share the XMD, but your data set must have the same colors. Otherwise, it won't work, guys. Because the XMD depends on the columns that... Yeah.
Yep.
And the JSON of the visualizations. I can share some with you guys. So I maybe Sayantani, I don't know. We can create, I don't know, a folder. I don't know how.
I'll create a folder.
But I definitely can. Okay, I can share.
Okay, thank
then
you.
I can
create
share.
a folder, and we'll add that later on when Philip gives it to me. But look out for the recording later this week. And thank you everyone for joining. Thank you, Philip, for doing this. We had an amazing, amazing start to the new year. So thank you.
Really appreciate it. We want you back. Will you come back
Much
in a couple
appreciated. Sure. Let's do.
Yes, started attending our meetings.
Yeah, we might need it in smaller doses next time. But yes, let's have you back for just a refresher for everyone in like 3 months. That sounds great. Thank you so much. I learned so much. I know somebody else did. And keep that recording, because when you're asked to do it, now you know.
Okay. Precisely.
And you know whom to contact if you don't get where you are going with it.
Yeah, exactly.
Thank you very much, guys. It was an honor, and it's always good to be in presence of such wonderful women that knows much more than I do and are true legends of the analytics platform. Much appreciated.
I can't find my keys in the morning.
Me neither. So
yeah, we all have data brain on here. So thank you so much. You'll need a rest. Go do some self-care after all that talking. And for everybody on here, you know where to find us if you need us, and think about all that. And if anybody else wants to volunteer up to share what they've done, come to us. We'll feature you too. So thank you.
Thank you. Bye, guys.
All right, everyone, have a great day.
Bye.
Bye. Take care.